Hello, this is Munelin Music. Today, I would like to introduce the discoveries of future theoretical physics that appear in Möbius chapter 2. The discoveries of future theoretical physics in Möbius. Number 1. The universe is connected vertically. In Carl Sagan's Cosmos, there is a passage like this. There is an idea, strange, haunting, evocative. One of the most exquisite conjectures in science or religion. It is entirely undemonstrated. It may never be proved, but it stirs the blood. There is, we are told, an infinite hierarchy of universes. The main characters who share Carl's thoughts reveal that stellar systems, including the solar system, are atoms of the upper dimensional universe, while the countless atoms in our universe are stellar systems of the lower universe. Therefore, they suggest that the Earth is an electron orbiting the atomic nucleus of the upper universe, which is the Sun. Doesn't this sound familiar? Yes. It is sad that people had similar imaginations when they have just discovered the composition of the atoms in the 20th century. They found that atoms contain atomic nuclei and electrons. However, it was proven to be a fallacy when they realized if the Earth carries a negative charge, it should generate a magnetic field while orbiting the Sun. And as a result, it would lose energy and fall into the Sun's orbit. Excuse me, wait a moment. Didn't you just say that the Earth orbits around the Sun? Do you know how immense amount of energy is that the Sun pours onto the Earth? The midday sun can instantly scorch us and evaporate the water in a large lake in the blink of an eye. The Sun constantly showers the Earth with such immense energy, and you are saying the Earth would lose energy and fall into the Sun's orbit? Instead, wouldn't it be necessary to somehow constantly lose the energy that the Sun emits in order to maintain the Earth's current orbit? They are stubborn like this. So, they persist in developing this classical imagination. Number 2. The principle of complementarity. Why can a particle be both a particle and a wave at the same time? The complementarity principle states that opposing physical quantities can complement each other to form a unified description of a substance or system. What does it mean? For example, a photon is both a particle and a wave. Both aspects are true. The Möbius characters imagine the upper and lower universe.
and they come to realize that each and every one of us is a vast system where the stellar systems of the lower universe serve as atoms. Therefore, even though the lower universe may be a vast cosmic space, it can be perceived as a small object to us. When we observe an object, we can see the entire space it occupies at a glance. So we can also see the entire time the particles occupy. It's because space is time. Therefore, particles can be observed as particles in our eyes, but they can also be observed as waves because they simultaneously exhibit the appearance of vibrating or moving over a long period of time. Additionally, protons and neutrons are not individual parts of a nucleus, but rather the different ages of a nucleus. Protons represent a main sequence star during hydrogen fusion, while neutrons represent a white dwarf star after its death. We observe both protons and neutrons simultaneously because we can see all the moments which atoms exist. Another character asks a question. Electrons are particles that cannot be distinguished from each other because they have the same charge and mass. However, if you look at the planets in our solar system, aren't they all different? How would you explain this? Here's a hypothesis regarding that. Every point in our universe is in motion. Because of this, we cannot observe a single object from a perfectly stationary point where we want to measure its velocity. Just looking at the Earth, its rotational velocity is about 0.46 kilometers per sec, and its orbital velocity is 30 kilometers per sec. Let's add them together. The Sun moves individually within the galaxy, adding its velocity of 20 kilometers per sec. The Sun is also following our galaxy's rotation, and its velocity is about 220 kilometers per sec. Add them. Furthermore, our galaxy is being pulled by the gravitational forces of the local galaxy group, adding its velocity of about 600 kilometers per sec. Our local galaxy group is also being pulled by the gravity of the Virgo cluster, adding its velocity of about 1,000 kilometers per sec. By continuously adding these velocities in this manner, we come to realize that we are flying through this universe at a much faster speed than we originally thought. No matter what method we try, it seems challenging to measure the mass of other planets from a perfectly stationary point. On the other hand, an observer of the upper universe, let's call her Scarlett, would be able to see the true velocity of the Earth because she observes the Earth from outside through the stationary boundary of our universe. Let's imagine Scarlett measuring the mass of the Earth. Scarlett could also observe our time, right? It's because space is time. In that case, from the perspective of the stationary boundary of the universe, Scarlett would be able to see our space-time and accurately determine our velocity and direction. She would simultaneously observe the mass and how much that mass curves the surrounding space-time. Similarly, she would observe the velocity and direction of Jupiter, its mass, and how much it curves the surrounding space-time. The hypothesis is that if we could observe all of these simultaneously, the masses of all planets would converge to a single value. When I was young, I loved the encyclopedia. From the pictures in it, I noticed a resemblance between the solar system and an atom. This sparked my imagination about the dimensions of the upper universe and the lower universe. This imaginative concept, which existed only in my mind, was brought to life in Möbius. The reason was simple. I wanted to go and see what the upper universe looked like. Of course, if I could go to lower universe, I definitely would. So, I decided to send the characters of Möbius to the upper universe on my behalf. In the process of transforming the vertical dimension of the universe into a theory of the future, astonishing discoveries were made. Number 3. One of the most remarkable things is the identity of dark matter. It's simpler than we thought. If the proton represents the main sequence star of the lower universe, and the neutron represents the white dwarf of the lower universe, the following question arises. When a black hole collapses under its own gravity, after the star in the lower universe reaches the end of its lifespan, what does it look like from the upper universe's perspective? Since Scarlett can observe both space and time simultaneously, all stars that will eventually collapse into black holes are observed as both the main sequence stars and the black holes at the same time. They will then be objects that have disappeared beyond the event horizons of the black holes, no longer visible to the naked eyes. But they will undoubtedly exist and become something that exerts an extremely strong gravitational field. We call it dark matter.
You're coming closer, closer, closer. You're growing as big as our
Number 4. Based on the mathematical proof of the superstring theory, the characters reveal that our universe consists of a total of 11 vertical dimensions. We exist in a three-dimensional universe. The universe began with a singularity known as the Big Bang, which is a point or a zero-dimensional universe. This zero-dimensional universe first expanded to a one-dimensional universe as a line. Then it evolved into a one-dimensional line universe and further expanded into a two-dimensional universe, incorporating an additional plane dimension of universe. In this way, the universe exists as a three-dimensional space universe, a four-dimensional time universe, a five-dimensional light universe, a six-dimensional particle universe, a seven-dimensional mass universe, an eight-dimensional gravity universe, a nine-dimensional electric force universe, and a 10-dimensional magnetic force universe, comprising a total of 11 dimensions.
The energies from the 0 to the 4 dimensions create the place where something exists. On the other hand, energies from the 5 to the 10 dimensions fill that place.
The names assigned to these dimensions are based on the order of the universe's phase transitions. After the first space-time was created, light must have existed in it. If there was light, particles must also have been created. When particles were created, some of them must have had mass. Mass generates gravity. When molecular clouds had enough gravity, they would have started a process of hydrogen fusion, which according to Möbius creates electric force. Because in the Möbius world, star systems are atoms. When electric force exists, magnetic force is also created. So, I would call these progressions the phase transitions of the universe. The reason the boundaries of the vertical dimension of the universe are divided is because the speed of light is not continuous but quantized. The speed of light in our universe is c. In the upper universe, it is pi c. And in the lower universe, it is c over pi. Therefore, when people observe particles under the light, when its speed is c over pi, the particles exhibit both position and momentum, becoming a state of the certainty principle. That speed of light corresponds to the speed of the electromagnetic wave emitted by the stars in the lower universe. We cannot see or feel the upper and lower universes. Therefore, it is easy to think that they do not exist. However, even by just looking at our own universe, everything in the world is the result of emergence, overlapping. Okay, what is emergence? It means that when particles or things exist individually, they don't show their properties. But when the particles or the things come together in astronomical numbers, they give rise to their own characteristic properties. For example, a water molecule consists of 2 hydrogen atoms and 1 oxygen atom bonded at an angle of 104.5 degrees. If we could catch a single water molecule floating in the air with our keen eyes and observe it, we would have no idea what properties it would exhibit when it comes together in astronomical numbers. We cannot anticipate its structure when it forms a solid at a certain temperature and pressure. What color and taste it will have when it becomes a liquid at another temperature and pressure. Or what smell it will have when it becomes a gas at yet another temperature and pressure. When observing a single water molecule, we have no clue.
However, when they assemble in astronomical numbers to form rivers, oceans, clouds, and snow, we can observe properties that emerge at the collective level. The crystalline structures of solids emerge through hexagonal patterns, creating beautiful forms. Liquids emerge with properties that primarily reflect blue light, making the ocean appear blue. Gases emerge with properties of being colorless and odorless.
Let's consider our bodies. Our bodies are composed of atoms. However, when we go to the hospital to treat our illness, we don't say the 520 billion, 36 million, 721,399th atom attached to my finger is weird. We have the ability to control our bodies at a level that goes far beyond the atomic level.
Atoms come together and emerge as DNA double helix structures. And these structures exist in the nucleus of the cell. These cells come together and emerge as an organ-level world. The organs come together and emerge as a human being. When human beings gather and disperse, they emerge as societies. Many organisms, including humans, come together and emerge as the Earth's ecosystem. The Earth is a planet in the solar system, and many stars, like the solar system, come together and emerge as a galactic level world. Galaxies come together and emerge as galaxy clusters, superclusters, filaments, and the large-scale structure of the universe. Atoms constantly emerge into the larger words. Everything emerges. Is there any reason why the large-scale structures of the universe should be the end? Is there really no higher dimensional world that emerges from the many large-scale structures of the universe? Should we believe that they simply don't exist because they are not visible to our eyes?
You're growing as big as our galaxy. For us, 4 billion years later, we start to dance with our galaxy world.
Number 5. Complementarity of time. Our universe is the three-dimensional space universe. Therefore, the dimensions of the higher universe, which are point, line, and plane, do not appear complementary to us. The dimension of our universe, which is the space, doesn't appear complementary to us as well.
The reason is that these energies are already unfolding within our universe as dimensions.
So, the dimensions of the lower universe, which are time, light, particle, mass, gravity, electric force, and magnetic force, can only appear complementary to us. Now, we have a friend who lives in the upper universe, Scarlett. If she observes our space, which is the most common thing to us, it would appear complementary. To explain the concept of space, she would have to borrow a particle of space and squeeze her head while explaining. Well, I understand that other things are complementary, but how can time be complementary? How can we know that? We can understand by looking at the sky. Where did the farthest light come from? The farthest galaxy we have discovered was born 13.4 billion years ago, which corresponds to the epoch of ionization, when the first stars formed. That light started from the universe shortly after the Dark Age. So, when we look at the farthest end of the sky, what are we ultimately seeing? Yes, it's the Big Bang. At the end of every point in the sky, there is the starting point of the universe, which is the Big Bang. Since we can plot an infinite number of points in the sky, those points are eventually connected by a plane. In other words, every point of the celestial sphere amounts to the Big Bang. If time were not complementary, then this cannot be explained.
Our galaxy will bend like a bow. Yes, we are going through each other, but don't worry.
Number 6. Spin of the particles.
The lower universe is a four-dimensional universe. Therefore, the celestial bodies in the lower universe would have a spherical shape in 4 dimensions. In our universe, they would be particles. We can unravel the mystery of particles' spin by further developing this idea. When we observe particles, regardless of our viewing angle, their rotation always follows either a clockwise or counterclockwise direction. If a particle is imagined as the smallest possible bead, when we view it from a diagonal direction of its rotational axis, the particle should rotate diagonally. However, the mystery of the particles is that no matter which direction we observe them from, that direction always becomes the rotational axis of the particles. Since Scarlett can perceive the time of the lower universe, she can see all the states of rotational axis that the particle had while existing. It is as if she can see inside the particle. Scarlett observes the three-dimensional sphere as a disk. Why? She lives in a two-dimensional universe, and that dimension can have from point to plane only. A universe cannot have any dimension with larger constant values than its number. A disk has a point-dimensional axis. The central point will inevitably meet the line-dimensional axis at the exact center of that three-dimensional sphere, regardless of the direction she observes from. Scarlett always perceives the central point that meets the line-dimensional axis as the rotational axis of the particle. If a circle has a point of the rotational axis in the center of it, the rotation can only be in either a clockwise or counterclockwise direction. Therefore, Scarlett would always observe the rotation of particles in either a clockwise or counterclockwise direction. Now, we are going to observe a word that has a larger integer value. A sphere of the three-dimensional universe always has a line-dimensional axis. Therefore, a particle, which is a star system of the four-dimensional universe, must have a plane-dimensional axis. Our universe cannot have this because it is a three-dimensional universe, but we can imagine it. The central line will inevitably meet the plane-dimensional axis at the exact center of that four-dimensional sphere, regardless of the direction we observe from. We always perceive the central line that meets the plane-dimensional axis as the rotational axis of the particle. If a sphere has a line of the rotational axis in the center of it, its rotation can only be
clockwise or counterclockwise. Therefore, we would always observe the rotation of particles in either a clockwise or counterclockwise direction.
We are going through each other, but don't worry, we are not doomed, so we will not crash.
Number 7. The identity of the photon and the electromagnetic wave. When we observe particles, interesting things happen. The particles make interference pattern on a far installed screen and exist as waves. However, when we shoot photons, suddenly they appear as particles. The characters of Möbius imagine even more fascinating scenarios with the widely known experimental result. They say that light is a dimension that governs time, and it has the ability to show only a single random moment. Due to this ability, the inhabitants of the universe mistakenly think that they only experience a specific moment in time, and that specific time is the present. As the characters of Möbius begin to think of a photon as a present particle, they discover that a photon is part of a time particle. The nucleus of the time particle consists of heavy future particles and past particles, similar to protons and neutrons. Orbiting around them is a present particle with zero mass, zero volume, and zero electric charge, which is precisely what we know as the photon. However, as humans possess the time sense to perceive only the present, we cannot see the nucleus of the time particle. Inside the nucleus, past particles have negative charge, while future particles have positive charge. The characters of Möbius call it time charge. However, inside the nucleus of our universe's time particle, there are more future particles than past particles, resulting in a constant positive charge. It's like an atom with more free electrons being negatively charged. If this is true, we can explain why our universe's time always heads toward the future. So, the time particles in our universe are always positively charged in time charge. Then, what happens when the particles shake? A space field is generated. The space field then generates the time field, and the time field generates the space field again. Through space-time induction, and the cycle continues, creating space-time waves. These space-time waves are precisely what we know as
particles. Doesn't this sound familiar?
Yes, just like an electron's accelerated motion. When you shake an electron, it is similar to a change in current.
When the surrounding magnetic field changes, it induces an electric field. And the electric field induces a magnetic field. Through this process, electromagnetic waves are generated. I have mirrored this phenomenon in Möbius.
When a single photon drifts through space, nothing much happens. However, when countless photons become friends and gather together, they align in a straight line at an incredible speed according to the present particle's orbital diameter, transmitting a wave at that same incredible speed. A single photon is merely a particle charged with time in their nucleus. But when they gather in astronomical numbers, they have the property of aligning according to the present particle's orbital diameter. This alignment enables them to transmit a wave that perfectly matches the present particle's orbital diameter at the speed of light, c. Since this wave has a wavelength twice that of the photon's orbital diameter, it would resemble an egg carton filled with eggs on both sides. Here, the eggs are the photons, and the carton is the electromagnetic wave. In this form, what emerges is the electromagnetic wave.
We are not dumb, so we will not crush. 5 billion years later, the patterns faded. 7 billion years.
Number 8. The reason why neutrinos arrive before photons when a supernova explodes. There was once a claim that neutrinos travel faster than photons. However, this was concluded to be an observational error and ended as an incident. But people observe that neutrinos run faster than photons, even in the era of Möbius. People are perplexed and suspect that the secret is hidden in the life and death of stars, and in the nucleus, in the middle of a photon's orbit. They propose a hypothesis that when a star is born and begins hydrogen fusion, the surrounding space-time is pushed into the past. And when a star dies and undergoes a nova or supernova explosion, the space-time around the star is pushed into the future, as if the star is trying to live just a little longer by pushing the space-time around itself in either direction. The characters of Möbius intuitively guess that the birth and death of a star will activate the particle's within the nucleus of the photons. And that this moment will be the only chance to observe those past and future particles. So, when a supernova explodes, the space-time around the star will be pushed into the future, activating the future particles inside the photon's orbit. The photons with activated future particles will arrive more in the future compared to their original expected arrival time. That's why they appear to arrive later than neutrinos, which can travel at high speeds due to their lightness and small size. The characters of Möbius artificially create a similar environment where stars are born and die to conduct experiments. What is this similar environment, and what are the results? You will have to check it out when Möbius is published.
7 billion years later, we're almost one. There's no up and down, there's no left and right, no line of gravity in and
Number 9. If you can observe the moon from the upper universe, what does it look like? Why can planets, including Earth, be observed as electrons from the upper universe? The reason is quite simple. It's because they actually carry a negative charge. How so? The characters of Möbius pay attention to the birth of stars. When stars are born, they cry out and emit bipolar outflows. As molecular clouds in stellar nurseries gather and begin forming stars, the matter undergoes a plasma state where electrons and protons separate due to increasing pressure and temperature. Finally, as the bipolar outflows occur, a star is born. Imagine that those bipolar jets primarily contain electrons. If that's the case, primitive planets that start to take shape while orbiting around them would receive an electron shower and acquire a negative charge. It is said that solar winds primarily contain protons, as if confirming the notion. If the satellites were still in form gas and had not yet taken shape when the star underwent bipolar outflows, the electrons would have simply passed through that gas. Therefore, the satellites that are born relatively late would appear as very small particles with a neutral charge when observed by Scarlett. Do we have something like that in our universe? Yes, neutrinos. However, the moon is made up of Earth's crust, so it would be observed as a particle carrying a negative charge orbiting around an electron. So, for Scarlett, the moon would become a rather special neutrino. No, an electrino, right?
no line of gravity in entire world. So my dear, we are
The introduction to chapter 2 of Möbius ends here. Did you sleep well? No. Did you have fun? Your head might have hurt a lot as well. I understand. I have experienced many headaches during the 15 years I've been writing Möbius. They say that in order for an author to publish a book, they need to write it in a way that anyone can understand easily. Unfortunately, due to my shortcomings, this book seemed difficult to understand without prior knowledge. Nevertheless, I am grateful that the universe sent me this story. So I have done my best to write the story, write its introduction for preview, record it, and add subtitles to reach all of you. Among them, the story of the upper and lower universe is deeply moving. Have you ever been moved by the beauty of the universe as you gazed up at the night sky? Similarly, when the inhabitants of the lower universe within your body look up at the universe, there will be many stars and galaxies there. Even in moments when you feel worthless, remember that you are a being that brings the magnificence of stars and galaxies to the inhabitants of the lower universe living within you. In the next session, I will introduce the mysteries of the deeper universe and the discoveries of future theoretical physics in chapter 3 of Möbius. Thank you.
we